Hello Fire Tech 102 students. This video is going to be the second part of chapter 14, which is fire suppression. And we're going to cover sections 3 and 4, which is supporting fire protection systems and then also building utilities. Okay, so this is going to go from slide 69 through 103. And we'll go ahead and get started with this lecture. And then again, this will be in the quiz. And then we're going to move on to section 5, vehicle fires, in the next module. And then we'll close it out with our last couple of sections, which are ground cover fires and outside Class A fires. All right. So let's go ahead and get started with this chapter 14, fire suppression, part 2 lecture. Supporting fire protection systems. So when we start talking about fire protection systems, we talk about sprinkler systems and standpipe systems that we're going to find in several different type of buildings. Usually it's going to, the sprinkler systems or standpipe systems are going to be, it's a large riser that is going to typically be found in the hallways, and it's going to go up all of the floors. So when we talk about a high rise, whether it's commercial or residential, we're going to be able to hook up our hose lines to that riser through what we call fire department connections on the outside of a building. So we'll get a hydrant that flows water to our engines, and then we'll flow water into those FTC or fire department connections, and we'll put water in that standpipe system. Standpipe systems also feed the sprinkler system. So those are the horizontal piping members or piping components that come off on each floor, and then you have the sprinkler systems that come down. What we use the standpipe system for, and it could be used to flow both sprinkler systems and the standpipe for us, is we'll hook up in the hallways. There'll be a valve on there. We'll turn the valve. We'll set our hose line up to make fire attack in the hallways. Okay, so what are fire protection systems? Protected structures feature of fire protection systems are typically going to be automatic sprinkler systems or standpipe systems. They can be found in both residential and commercial. They can be found in single-story commercials as well. The standpipe system can be found, or sprinkler system can be found. All right, so it doesn't necessarily have to be multiple floors, right? Typically, when we refer to a standpipe, we're going to refer to the vertical pipe that supplies the sprinkler system and supplies us with water we need for fire control. And what do we use these for? We use these protection systems. They work. We work with the system so that we can control the fire. Automatic sprinkler systems are designed to increase the survivability of occupants and firefighters during the structure fire. So basically what they do is they will be triggered by heat, by smoke, by some kind of detection device. Those sprinkler heads themselves may have a fusible link or a frangible bulb, which at a certain heat level, the fusible link will melt. The metal in it will melt, and it'll open up that sprinkler system so water can flow through it. We have wet systems mostly here. Wet pipe systems, which means water travels through that system all the way to the sprinkler head. And then once that mechanism, whether it's a frangible bulb, which the bulb will break at a certain heat, or the fusible link where the metal pieces in it will melt, they're soldered on there, those will melt, they'll fall apart. A disc will be released from the orifice where water will flow out of the sprinkler head, and then water flows. So there's what's called a deluge system where all of those sprinkler heads will go at the same time, but then most of our sprinkler systems we'll find will only activate a certain area based on the conditions. So you have fire in an apartment, one apartment. That apartment's got maybe 2 sprinkler heads in there. Depending on the size of it, you're not going to get every single apartment building activated. The smoke or the heat will go to the alarm or the detection device. The detection device will alert that there's smoke or fire. Then whatever mechanism holding that sprinkler together will release, and then it will cause water to flow in that area. The sprinkler system doesn't necessarily put the fire out, but it'll keep that fire in check, keep it from spreading, right? So now what's happening is the smoke and gases are not heating up. They're not heating, it's cooling, but it's also preventing the smoke and heated gases from heating other combustibles up within that compartment that it's in, or room, or if it's a bedroom or a kitchen or whatever. Most fire sprinkler systems are designed with a control mode sprinkler. Uh, Connecting to the fire department connection. This is what you're going to see on the outside of a building. You'll want to be familiar with the buildings that have standpipes in your area because you're going to want to know where you're going to hook up to that structure. All right. You're going to want to know what kind of fitting is on there. Is that fitting a male fitting? Is that fitting a female fitting? Typically, it's going to be a female fitting, which is non-threaded. And your threaded end, which is the male fitting of your hose line, your supply line, is going to go into that fire department connection. So this is one of the first priorities is connecting a pumping apparatus to the FTC. Once the order is given to connect to the FTC, locate it, select the proper supply hose, and then make your connections. You're going to connect to your engine. You're going to connect to the FTC. You're going to get a hydrant to supply the engine with water so it doesn't run out. And then you're going to flow water in there. And you want to identify these like doing building walkthroughs and other pre-incident plans. Closing a main control valve. One method used to stop water flow from an activated sprinkler is to close the system's control valve. These are located between the sprinkler system and the main supply. So sometimes you can shut it down to a floor. You can isolate it to a floor. Sometimes you can isolate it to a room. Sometimes you have to shut down the entire system. We don't really like to shut down the entire system if we can isolate it to the floor. So let's say you have a 10-story high-rise and you have a fire on the 8th floor, and on that 8th floor you have a sprinkler going, and you can shut that water down to the 8th floor while all the other floors remain intact. That's what you'll want to do. All right. This is usually located directly under the sprinkler alarm valve, a dry pipe or deluge valve, or outside of the building near the sprinkler system that it controls. Some systems are designed with sectional valves to shut down small areas or shut down individual sprinklers. Some you have to shut down the entire system. It really depends. You'll want to become familiar with that. And these are either secured in the open position with a chain or padlock, or they're electronically supervised. So they're opened up, the valves are open, you have a chain on it, or you have a padlock on it so that you can't turn those without breaking them, or it has an alarm device which is electronically supervised. So if there's a disruption in that water flow because you shut that valve off, it's going to send a trouble signal to the alarm panel. Shutting the sprinkler control valves. You see this person's shutting valves. They found it. This would be your alarm, having it electronically controlled or monitored. Okay, so that's going to be a device that's going to let it know when there's tamper with it or something like that. Should only be done once fire is under control and the IC has given the order to do so. And then a firefighter with a portable radio should be stationed at any control valve that has been closed so the valve can be reopened when necessary. Depending on your department policy, we don't recharge the systems. We don't fix the systems. We'll put the building on fire watch, and then they'll have to get their system fixed because we don't replace sprinkler heads. They'll have to have somebody come out and do that. And then once that's done, they can get their system certified by an inspection company and then charge their system back up. Small departments prefer to plug active sprinklers individually rather than close the fire suppression control valve. Yeah, you can take, there's devices that we have where you can put that in the actual sprinkler head, and it'll essentially act like the disc in either the frangible bulb or the fusible link. It does the same thing, right? It basically, you put this in there, get quite a bit of water that comes out, and then what you do is you open this mechanism up and it plugs the sprinkler essentially. Some people will do it with wood wedges. They'll hammer 2 wood wedges together to cover that hole where the water is being discharged. And then you can basically you're controlling the water there at the sprinkler head as opposed to shutting down the entire system. Some types of indicating control valves. You have your OS&Y, which is outside screw and yoke, sometimes referred to as outside stem and yoke, or the OS&Y valve. You can see that this is open because you see that there is the stem, right? When the wheel is at the end of the stem, it's closed. Okay, so and this is locked open. Your post indicator valve, that will say open or shut on it. A lot of times this key right here will be locked on the side, so you break the lock and then you can use this wrench to open or shut it. And then you have the wall post indicator, right, which is essentially a post indicator, but they're wall mounted. and then you have a post indicator valve assembly there. Stopping the flow from a sprinkler, you see that there's a couple methods. There's tools that you can use that will do that, and then also you see somebody using the wood wedges here. So there's a tong type tool that you can use that will close it. Again, our department doesn't. It's not in the business of replacing sprinkler heads. The responsible party or the building occupant needs to do that. So once a fire has been brought under control in a protected structure, stop the flow from any activated sprinkler to minimize water damage to the structure and its contents. Yes, it causes a lot of damage when those sprinkler heads go off. So we want to make sure that we get the fire under control, get it knocked down, and make sure that those are the water flow is stopped as soon as we can. Sprinkler tongs or stoppers and wooden sprinkler wedges, those are often used to stop the flow and are suggested for having a sprinkler kit, which we have a kit for sprinkler systems. The authority having jurisdiction determines the responsibility for restoring automatic sprinkler systems to service. You may only restore the system if you're authorized and trained to do so. Again, like I said, we don't do that. We used to, but we used to replace sprinkler heads and then we would turn the system back on. But now the building owner or occupant or responsible party has to call out whatever company they use to certify their system, and they'll come out, they'll replace the sprinkler heads, they'll charge the system, test the system, make sure it's functional and operational, and then they'll get it signed off so they can no longer be on fire watch. And what a fire watch is for us is it's a 24/7 watch where somebody has to walk the building and ensure that there's no fire every half hour, and they're signing for that. Okay, we're going to move on to utilities. So as far as utilities go, right, we really want to control utilities. When we talk about utilities, gas, electric, we want to get those shut off early because both of those could cause problems during a fire. Water is another type of utility. We don't always need to shut the water down. Sometimes we may need to in the case of like the sprinkler systems where we may have to shut it down if we can isolate it to one area. But gas and electric, we want to get on that early, especially if we have a fire going, so that those two utilities don't cause additional problems. Controlling building utilities may help control the fire and limit damage. Shutting off utilities may enhance firefighter safety, especially when performing overhauls of walls or ceilings. Where does our electrical run? Where does our plumbing run? And where do you have gas? You have it in the walls and the ceilings. A lot of times gas will be underground. I do have gas that runs through my attic as well as gas that runs underground, but all of my electrical runs through my attic space. I do have plumbing or water that runs underground to a couple of different areas. All right, so there is plumbing and electric that runs through the walls as well. The IC or supervisor will determine which utilities must be controlled and will assign that task to you. Locations and means of control will vary depending on the types of structures. Yeah, you'll get very proficient at utilities. Essentially, what you want to do is you want to understand how an electrical panel works and how you can shut off the breakers, how you can shut off the entire panel, how you do it safely. You want to understand how a gas meter works, from where the gas comes in from the outside, goes through the meter, and then goes to into the home. And you want to understand how to shut off the water. Okay. So you can shut off a lot of those things at the street, or you shut them off at the house, right? So I have multiple water shutoffs on my house that I added so that I can isolate where the water is actually shut off if I need it. And it's faster to get to if I have a leak. Electricity, I got to shut it off at my panel. I only have that one panel that's on the end. And then if your electrical company comes out, they take off your meter, and then they boot your meter, right? They put a little cap over your meter so it won't run, so you can't run electricity through it, and then they'll lock it up, right? So when we have fires, we want to get those secured. Water, we can also shut our water off at the street, and then gas typically is shut off at the gas meter. So you'll want to understand how to find those on a residential and a commercial property. Fire department personnel are not responsible for turning utilities back on and should not attempt to do so. Matter of fact, when we have a fire, we assign a company to secure the building, and then we call for Edison, we call for the gas department, and we call for the water department. So the city that I work for, Edison typically does the electrical for the whole city, and then the utility department does gas and water. All right. Conditions specific to building utilities should be observed and communicated. Location of the utilities, electric, gas, water, where those meters are, how to shut them down. Status of the power to or within the structure, are these on or off? Right. So somebody will be given that assignment. Do you have any broken pipes, down power lines, or are there any unauthorized modifications to those utilities? Right. So again, look for those things. Right. Do you have any alternative utility sources? Solar panels? Do you have any LPG tanks for gas? Do you have any kind of electrical storage system along with the solar panels? Right, you'll see those, especially people that have electric vehicles. They have charging units, they have a battery system that stores energy, so you'll see those things. Those are becoming more and more common as you see more electric vehicle charging stations at people's homes. Electricity usually comes from an electricity utility company or an alternative source, solar or whatever the utility company is. Some cities have their own. Some use Edison. So I live in the city of Anaheim. City of Anaheim has its charges you for electric and charges you for water, but gas comes through SoCal Gas. Okay, so they don't have all three major utilities. They have two of the three. Electric service must be disconnected when there's a structure fire unless the IC otherwise orders. So somebody's going to be sent to the panel to secure the electrical. You're going to be given the assignment. You're going to let them know that you understand the assignment, and then you're going to let them know when the assignment is complete. In some cases, structures are total electric, meaning electricity is the sole power source. In others, electricity provides only lighting, while forms of gas provide hot water, heating, and cooking, right? So yeah, do these have an electric stove or do they have a gas stove, right? So you'll want to walk around the structure and look for all three: gas, water, and electrical. When shutting off building utilities, assume there's an alternative source of energy present. Always use caution and refer to local policy for further guidance. Electric utility supply source. Commercial power companies provide electricity in urban, suburban, and rural areas. Electric lines connect structures to the main power grid. Electric meter is the primary location for shutting off the power. So you'll find the meter, or the meter is typically next to the panel. So we shut off the electrical panel. Remember, there's above ground power. So if there's certain cities, if you live in cities where you have power poles that run and you have lines that run from those power poles to the roofs of houses, that's above ground. Where I live, we have below ground, right? So we have underground power. So it's all been trenched and it goes to the houses underground, right? So you can have above ground or below ground as well. But everybody still has a meter on their home and everybody still has a panel. In commercial, industrial, and institutional occupancies, pre-incident surveys should be done to identify the location of the power source. Yeah, become familiar with the buildings in your area, right? When you go, you have a fire, where are we going to shut off utilities? How are we going to get into this building? You're basically going to pre-plan how you want to attack a fire in those buildings. Safest way to cut power to the structure is to follow your department's SOPs. Contact electrical power company to perform the shutdown. Both high voltage and low voltage systems may be found in a building. Yeah, so we want to really be careful with that. All right. We get the electric company coming as soon as possible. Really, what we do is we try to shut down the panel, because the panel is the safest way to shut that down. Keeping the power off. If the power is shut off to the entire building or any device in it, the main power switch should be locked out and tagged out. So you want to make sure that we know it's out, they lock it out, they tag it out, so that nobody can go and turn it back on, right? We want the electric company to come in and turn that back on. If lockout, tagout devices are not available, assign somebody with a portable radio to stand at the switch. Typically, we take over the structure and we have crowd control, so people aren't walking around the structure messing with the electrical. But that's an option, is to have somebody stand there. Maintaining electrical supply source. Many structure fires, it helps to keep electrical power on to provide power for lighting, ventilation equipment, fire pumps, and other essential systems. The IC will make this decision in consultation with the incident safety officer. And when a fire involves one area of a structure, it would be counterproductive to shut it off to the entire building. That's why we want to shut it off at the panel, because then we can isolate it to the area that we need. When the building becomes damage to the point service is interrupted or electrical hazard is created, then the power utility should turn off the main panel, right? So we'll order them up early, right? In a fire, the incident commander will order them up pretty early. Whatever your department's policies or your standard operating procedures are, that's what you're going to do in order to ensure that you're shutting these things off safely, because those are going to correspond with how you've been trained to shut the utilities off. Alternative energy sources, solar panels, you're seeing a lot more of those, especially in the California area. Be alert for installations with alternative emergency power capabilities, solar panel arrays, electrical energy storage systems, wind turbines. We don't have too many of those there. Liquid or gas fueled generators. Some people have a generator in case their power goes out. And then solar panels are marked with red warning labels. Okay, so if you look at this structure right here, we just talked about vertical ventilation. So you're going to have to find a place that's safe to ventilate, right? Typically, we talked about just below the peak, but look, we have all this roof space that's already occupied with the solar panel. Generally, you have solar panels on one side of the roof. You don't typically have them on both, so you may have to be on the other side of that ridge to ventilate this room right here. Right. Most solar panel arrays have 2 shutoff switches, one on each side of the power inverter. Closing any of these switches will shut off the power inside the structure. It will not turn off the solar panel array. So again, those panels are still charged. However, inside where they're, maybe pulling the drywall off the walls, you've shut that electricity off. So the panels themselves are still charged. So you want to be aware of that when you're working around them. Fires involving solar panels present an increased hazard as the electrical current the panel produces cannot be effectively controlled. The current may travel back down the water stream and cause electric shock to the hose team. So again, we talked about that last time, those electrical fires, what's suitable for it. Water is a conductor of electricity. So a solar panel fire could be pretty dangerous. Once the fire is extinguished, the damaged panel still may produce electricity. So you always want to be aware of that when you're doing solar panel fires, if the solar panels themselves are the root of the cause of the fire. Solar panels generate current whenever there is a light source, sunlight, moonlight, artificial lighting, and are always energized. So keep that in mind. This is a big one here. Lithium-ion battery electrical storage systems. We call them a BESS, battery energy storage systems. Again, lithium-ion batteries, they're huge now. They're huge because lithium-ion batteries they're in everything. Your cell phones, your laptops. They're in bicycles, scooters, vehicles, right? And they pose a problem because of the toxic gases that they give off, and they're very unstable. So keep in mind that when you go to a home and they have a charging station there, they may have one of these energy storage systems there. Okay. In our city, we have areas that have buildings that contain these energy storage systems. All right. So you may have a fire there. Water's not necessarily the best avenue to get those done, to get those extinguished, right? So you want to make sure that you train on these. You make sure that you approach with caution and that you're following your department's SOPs when it comes to lithium-ion battery fires. All right. A lot of garage fires and house fires end up turning into a lithium-ion battery component, which becomes a hazardous material event or incident because of the gases that the lithium-ion batteries produce. All right. So these present a new challenge for the fire protection community. You may encounter a structure that contains an ESS or a structure that is an ESS. Like I said, we have both, right? Lithium-ion battery units in an ESS, they can fail and go into what's called thermal runaway. So thermal runaway is essentially that exothermic reaction during which it increases in temperature and leads to more increases. So these batteries are stored in banks, right? So this battery gets going, it goes into thermal runaway. You can put water on it, it'll cool it down, but once you take that water away, it goes back into thermal runaway and it heats right back up. Well, now it gets that next bank going, that next bank going, that next bank going. You really want to remove that battery and then flood it in some kind of, sink it into some kind of water and allow it to go out, right? So there's still an evolving way of fighting fires with lithium-ion batteries or energy storage systems. But essentially, basically, what that thermal runaway is your lithium-ion battery starts breaking down, and when it breaks down, it starts heating up, and you're not going to stop that. You could try to cool it, you'll cool it, but really what you need to do is you need to get it away from the other batteries packs, right, or the other banks of batteries, because that heat from the one in thermal runaway will then cause the others to go into thermal runaway, and that's where you have a big problem. All right. Current recommendations include treating it as a hazardous materials incident. Yes, because you want your hazmat team to come up and you want them to monitor for gases. Okay. So hydrogen fluoride gas comes off. That's a big deal. And other byproducts of those lithium-ion batteries cause a big problem, right? Our people need to get their turnouts decontaminated. They need to take them off. They need to bag them up. Those turnouts need to be cleaned before they go back to the station, and all of their gear does as well. So decon is a big deal at these incidents. Approach ESS units with caution, protect exposures, delay entry until the scene can be rendered safe with a plan to handle both thermal energy and stored electrical energy. So you may not know that what you have is an energy storage system fire. You'll know if it's a building that's all energy storage system, and then that building's on fire. But if you go to a home that has a garage fire, you may not know that there's an EV in there that's charging and they have a battery pack in that garage. Okay, you might not know that. So that it stores energy there. So you want to be very cognizant of that. So we may be making an aggressive fire attack, and then we realize, hey, we got some lithium ion issues here. We're going to back out. We're going to call our hazmat team. We're going to make it a hazmat incident, but we've handled rescue, and now we're handling exposures while we get some air monitoring going. Wind turbines don't really have those. You may encounter a structure with a wind turbine providing electrical power. As you go like towards Palm Springs, you see a lot of those. In addition to or in place of the power company. Power can be turned off at the meter box with the main power shut off. The power line from the wind turbine to the meter will remain energized. So remember that, right? So anytime something's going to remain energized, you need to understand that. Generators. See a lot of people that have fuel power generators, and they're there to plug into their electrical system when the power goes out, right? So that sometimes you have them that they'll maintain like your refrigerators so that your food doesn't go bad, or they'll give you some sort of electrical source, but they won't power the entire structure. Sometimes they power the entire structure. Some are portable generators that you see at maybe residences, or you have generator backup systems at other facilities. Like all of your fire stations are going to have a generator system. Our fire department headquarters has a main system. So shutting off the generator should control these systems. If the system supplements power company service, shut off the supply at the meter box. All right. Gas. To control gas utilities, you must have a working knowledge of the hazards and correct procedures for handling incidents involving natural gas and LPG. Okay, so when we start talking about some of these gas issues that we have, there could be problems, because what you could have is you could have them in stored pressurized containers, and if those containers fail or those tanks fail, then you end up with a bigger issue. All right, so you have some of these stored gases in vehicles as well, right? So we have some natural gas vehicles. Okay, so again, we have our natural gas that comes in through the meter from the gas company, or you could have a tank. You could have a tank that has some kind of gas in there, propane, LPG, natural gas in that tank, that pressurized tank that feeds the occupancy. All right. Natural gas is lighter than air, so it's going to rise and diffuse in the open. So it's not too bad, right? Pure form is methane, which has a flammability range of 5 to 15%. It's non-toxic, but it can be an asphyxiant, so you're going to have your SCBA on anyway. Although natural gas has no odor of its own, they put this thing called mercaptan in there, and it's got a really bad odor, like that rotten egg odor. So when we have our refineries, when they're burning off some of the gas that's produced, they have that mercaptan in there, and you can smell that. So a lot of natural gas will put that additive in there so that you can smell it when there's a leak because it's odorless, right? So it is lighter than air, so it's going to rise and it's going to diffuse out in the open. Natural gas shutoff. So all of your shutoffs typically have a valve like this where you're going to be opens in line with the pipe, closed is perpendicular to the pipe, to the flow of the gas there, all right? So when you shut it off, you want to make sure that you have like a pair of channel locks or that you have some kind of other wrench, a pipe wrench, or some kind of other wrench that you can use to close those. Different valves for different size meters, right? The bigger the meter is, the harder it's going to be to close with a pair of channel locks, right? So you might need a pipe wrench, or you can use one of your other tools, a spanner wrench, or you can even use the forked end of your Halligan tool, right? Shutoff is inline valve located on the owner supply side of the meter between the distribution system and the meter. When the valve is open, the tank is inline, and then when it's perpendicular, it's closed. If you're shutting off the inline valve, it does not stop the gas supply to the structure. Take no further action and contact the utility company. So if it doesn't work when you shut that off, then something else is wrong, right? So then you want to talk to those inside and say, hey, we couldn't get the gas shut off, right? Contact the local utility company when the gas has been shut off or when an emergency involving natural gas occurs. So yeah, there's several different things that we need to do. We have the utility company come back and turn those on, all right? Whether it's gas, whether it's electrical, and there's a process that people have to go through depending on the extent of the fire to get their utilities restored. They have to go through like an inspection process with the city. Utility companies, not the fire department, they're responsible for turning the utilities back on, all right? Gas and electrical. Natural gas leaks underground and underground and wet soil can lose its odorant and become difficult to detect, right? So that means you're not going to be able to smell it. LPG. So when we refer to LPG, basically what you have is you have a gas that's used for fuel, but it's stored under pressure liquid and it's in a cylinder, right? So the problem with those cylinders is that as the cylinders pressurize, especially if they get heat on them and they don't have a place to vent, then they can explode. And then also, what are the explosive concentrations of the gas itself? So your two main categories are butane and propane. And if you want to see how butane looks, take a look at the LA City Boyd fire. That's a fire that they had, and there was a lot of butane storage, and it was bad. Really, really bad. Like you see the actual fire itself. So it's a really good video to watch. I'd encourage you to watch it, but there was a lot of butane storage there. And then propane, that's the most widely used. LPG, it's about 1.5 times as heavy as air, so it's going to sink and it's going to disperse around the ground, right? And not to mention that now it has an explosive concentration between 2% and 9.5%. So you could have vapors that hang around, and then you want to have a fog stream of at least 100 GPMs. That can be used so that it dissipates the cloud of the unburned gas. So again, if you don't know that you're standing in that, right, its explosive concentration is very low. So it's going to sink. It's not going to rise and disperse, right? So it provides a pretty dangerous atmosphere. LPG is shipped from its distribution point to where it's going to be used in cylinders and in tanks that are on cargo trucks. So you're going to have it shipped. It's going to be like cylinders that are stored and they're under pressure. Or in a big truck that has a tank on it that has that stored in there. So you got steel piping and copper tubing that's going to connect your tank or your cylinder to your gas-powered appliances. And then you have a shutoff valve that's located at a point where the supply line from the LPG tank enters into the structure. All right, so there's going to be a shutoff there. You'll want to learn how those work as well. Okay. Water. So water shutoff valve, they're located within the water meter. So our water meter is out at the street, but then as you come up to our home, I have a shutoff valve in our garage where the water line comes up and goes into the house. And then also where your sprinklers are, where our sprinkler valves are, and there's a faucet outside that water comes up there as well. So learn how to use water shutoffs. And our supplemental videos that we have, those are all going to have your gas, your electric, and your water shutoffs. Okay. So commercial structures and large institutional and industrial facilities have larger diameter supply lines than residential's. So you're going to want to know how you shut those off. And then restoring water supply will be the responsibility of the water department or the building owner. And like I said, we call them in. We get a responsible party that'll come to the command post. We'll let them know, hey, the fire's out. We're giving the building back over to you. Here's the water department, gas department, and here's Edison, and they can help you get your utilities restored. Okay, so that's it for this part. That's part 2 of chapter 14, which is supporting fire protection systems and then building utilities. So we're going to move on into vehicle fires for our next lecture. All right, thanks everyone.